All right, problem number 13 on page 143 gives us a height equation. So it tells us the height in feet after t seconds of a ball that's been thrown into the air. That height equation is the y equation, or we could think of it as the position function. All right, we are supposed to find the velocity. And when it just says find the velocity, it doesn't mean average. When it says find the velocity at t equals 2, it is synonymous with saying find the instantaneous velocity, instantaneous rate of change. There are two ways to do this problem. The notes online have it one way, and I'm going to do it the other way on here so that might help. So I'm going to go ahead and say the limit as h goes to 0 because I know that I need to find the slope. So I'm going to use our slope equation, which is f of x plus h minus f of x over h. Now in this case, we actually know x. X is our t value, so I can plug that in. So this is actually going to be the limit as h goes to 0 for f of 2 plus h minus f of 2 all over h. And the reason we like this is that it actually gives us a little bit easier formula to work with. All right, so we have the limit as h goes to 0, and this will be, I'm going to go ahead and do my f of 2 plus h, so 40 times 2 plus h minus 16 times 2 plus h squared, and then minus, instead of writing f of 2, I'm actually going to find f of 2, and if I plug 2 into the y equation, I end up getting 16. So I know there's going to be minus 16 all over h. And now I need to just do some fancy algebra and expanding and simplifying. I'm going to leave off the limit part here, even though the limit still is there. I would have 80 plus 40h minus 16 times, and then it would be 4 plus 4h plus h squared, and again that's still all minus 16 over h. Alright, so now it's just some simple algebra that we need to do. We need to do the distributive property. So we're going to have our 80 plus 40h. Then when I distribute that 16 times 4, it's really 32 times 2, so 64. Don't forget to distribute that minus sign with that. So I have 64h minus 16h squared minus 16. And what we find is that this minus 16 minus 64 cancels with the 80. Everything left has an h with it. This 40h and this minus 64h are going to have a difference of negative 24h. And then I have the minus 16h squared, and if I divide everything by h, I end up with the limit as h goes to 0 for negative 24 minus 16h, and when I go ahead and plug 0 in, I get negative 24 feet per second. So that would be the instantaneous velocity for this ball in motion at 2 seconds.